Hello student, and welcome to the course Urban Rail Transit Tracks, Stations and Yards. Starting from this lesson, we'll explore the key part that plays an important role in railway intersections, which is called a turnout. Think about the last time you were driving and reached an intersection where you had to make a decision. Do you turn left, right, or go straight ahead? Each choice led to a different destination or route. Now, imagine a railway network as a vast transportation web with its own version of intersections. They serve as a guiding hands of the train tracks, directing trains to their intended path and ensuring safe and efficient travel. A railroad turnout, also known as a switch in North America or points in Europe, is a mechanical installation that enables railway trains to be guided from one track to another, such as at the railway junction or where the spur or siding branches off. They could always do whether they are parallel, diverging, or converging. Turnouts are essential because rail train wheels have inside flanges, requiring this special arrangement for navigation on the rails. On early railway lines, the movement of vehicles between tracks was accomplished using a method known as sliding rails. This technique involved the use of manually operated rails that could be moved or slide horizontally to transfer railway vehicles from one track to another. Sliding rails were a basic and early form of turnouts used in the railroads. The railway engineers used simple single-edged switches to move train between tracks. As iron rail plateways became popular in the 18th century, cast iron parts were made to build switches with check rails. In 1797, John Kerr described a system called plate switch using a single iron blade hinged to a vertical pin that tapered to meet a plateway. Plate switches are only used for double-flanged wheels, with wheels running through the plate on their flanges, guided by the edge of the plate and the movable blade. This type of switches can only be used by double-flanged wheels and at extremely low speeds. They are typically only found in hand-worked narrow-gauge lines. By 1908, Kerr's basic design was in common use. The use of spring rails to provide a smooth transition was patented by Charles Fox in 1838. The function of switches and crossings in a turnout are to enable railroads to branch from or to join up with one another, to provide flexibility within the road so that trains may move from one track to another track, and finally, to enable vehicles to be sorted out. In order to respond efficiently to these requirements, turnouts ought to have specific features. For most, they should curtail speed limitations to the bare minimum strategically positioned precisely where operational needs dictate. Their design must offer unparalleled operational versatility, accommodating diverse train movements seamlessly. Furthermore, these elements must withstand the prescribed axial load, ensuring structural integrity while being cost-effective to manufacture, straightforward to install, and resilient in the operation. Durability is a key necessitating resistance against wear, corrosion, and degradation, thereby demanding minimal upkeep. Additionally, their integration should seamlessly align with the signaling necessities, enhancing the overall efficiency and safety of the railway network. In a turnout, we can distinguish the main track and the turnout or divergent track, to which the vehicle can be diverted. The mathematical or intersection point zero of the turnout, which is a point where the axes of the two tracks intersect. The common crossing defined by the axis of the two tracks, the stock rail, which is a rail that stays motionless. The switch rail or tongue rail, which is a moving rail that changes the course of the vehicle. The check rail and the wing rail, which is a rail placed exactly opposite the frog to prevent the wheels from having irregular and uncontrolled movement. A turnout is designated as a right-hand or a left-hand turnout, depending on whether it diverts the traffic to the right or to the left. Turnouts are used to enable trains to diverge from the straight road ahead on the other line, or to stay on the straight road. When trains traverse a set of the turnouts in this manner, they are said to be traveling over a turnout in a facing direction. Of course, turnouts can also be used in the opposite direction, where two lines converge and become one. Trains using turnouts in this manner are said to be traveling over them in a trailing direction. Therefore, when standing at the toe of the turnout, if one looks in the direction of the crossing, it is called the facing direction, and in the opposite direction, it is called the trailing direction. Many turnouts are used for both facing and trailing train movements. Before going much further, we need to understand the principal part of the set of the turnout. The main components are shown in the diagram. Again, terminology varies somewhat both from one country to another. Switch rails, also known as the switch blades or tongue blades, are movable rail sections which guide the train along the straight or diverging road. They are tapered at their tips so as to fit closely to adjacent stock rail. Stock rails are the outer running rails for the straight and the diverging roads. They are not moving part of the turnout. The tips of the switch rail move up tight against the stock rail when in a closer position for the road set. In some cases, the switch rail can be heat-treated to improve its service life. There are various types of heat treatment such as edge hardening and complete hardening. The cross-sectional area of the switch rail also affects the performance. New tangential blades perform better than older blades. Turnouts were originally made with straight switch rail ending in the sharp pointed ends. This switch rail causes collisions and as trains pass in the direction of the turnout. The switch rail can be made with a curved tip that touches the stock rail at the tangent, allowing for less collision, but the downside is that the tip metal is thin and necessarily weak. Common crossing is part of the track layout where the switch rails converge. Of necessity, there is a gap in the rail here so that the wheel flanges can pass through. However, the existence of the gap can create problems, particularly on long turnouts. The common crossing is also called frog, which is taken from their resemblance most closely to the hoof of a frog. In Australian parlance, a common crossing is called a V-crossing or V-rail. Closure rails are a non-moving section of a rail that connect the switch rail with the common crossing. Check rails, also known as guard rails, are short sections of the rail positioned alongside the stock rail to ensure that the wheel follows the correct route through the common crossing. Check rails are also used on very sharp curves, even without the turnouts. It can be seen in the diagram that they are similar railed alongside and forming part of a common crossing. These are known as wing rails, and sometimes these are manufactured as a part of a common crossing rather than being separated rail. Stretcher bars are provided at intervals between two switch rails to help ensure that the correct distance is maintained between them not just on the tip, but throughout their length. Note that railways in many countries do not use stretcher bars, although they are used in Britain and some other countries whose railways are based on British practice. The number of stretcher bars is governed by the length of the switch rails, which in turn is determined by the maximum permitted speed of trains taking the diverging route. Switch hills are the demarcation point between the movable switch rails and the fixed closure rails. A hill block assembly is positioned in the vicinity of each hill to maintain the switch, closure, and adjacent stock rail in the correct relative positions. What the diagram depicts, but which cannot clearly seen in the picture, are the supporting elements for the rails. These include extra long sleepers, which support the rails. Sleepers are known in some parts of the world as bearers, ties, or cross ties. The rails themselves sit on chairs as does rail on plain line. Where the switch rail move, the chairs support both the stock rail and the switch rail. Their slide chairs, and as well as holding the stock rail in position, they also have a flat surface over which the switch rail moves laterally. To aid movement, these surfaces are usually greased or fitted with plastic inserts to reduce friction, or with the rollers, which lift the switch rails very slightly while they move. All these components work together to guide the train along the correct route, ensuring that the train can traverse points safely and smoothly, with minimal wear and tear on both the wheels and the track. Means that the design of points is a complex matter, particularly where points are very long for high-speed turnouts. In addition to guiding the movement of trains, turnouts also need to change direction according to the operational needs of different trains. A switch machine, also called a switch motor, point machine, or alternator, is an electrical, hydraulic, or pneumatic mechanism that aligns a point to one of the possible routes. The motors are usually remotely controlled by a dispatcher. This switch machine also contains electrical contacts that detect when the switch is fully set and locked. If the switch fails to do this, the control signal remains red, which means stop. The turnouts not only need to change direction according to the requirements, but also need to ensure that this position remains unchanged during the train operation. Therefore, it is necessary to loop the turnouts in place. A facing point lock, or FPL, or point lock, as the name suggests, is a device that locks a set of points in place and mechanically proves that they are in a correct position. The oncoming point part of the name refers to the fact that it prevents the point from moving during oncoming movement. If the point moves under the train may split the point, eventually down both tracks. If the point tries to move in during the trailing move, the wheels of the train will force it into the correct position, which can cause serious damage. This act is known as run-through. It's worth noting that the lock is only required when the train is approaching from the facing direction, because when the train is merging from the opposite direction, the forces exerted on the point blades only serves to keep the points in a desired position, and there is no risk to trains. As with detection, the facing point lock mechanism varies in design for mechanically worked and power-operated points. The mechanically worked facing point lock is used in some European countries, where a lock stretcher bar connects the two switch blades and it has two slots cut into it. When the turnouts are in required position, the signalman pulls the FPL lever. This is a separated lever, not the same one as is used to move the turnout. This lever is connected via routing to the lock rod, driving it into one of the two slots into the lock stretcher bar. This is one slot for the points in the normal position and the second for the reverse position. It can be seen that when the lock is engaged in one of the slots, it is impossible for the switch blades to move either by the signalman attempting to move the points lever or by vibration as the train traverses the points. It also shows the metal sole plates, also known as a stock rail gauge tie, on which the lock and the two slide chairs are rigidly mounted to prevent movement and maintain the correct gauge at the switch tips. Now let's move on to the powered-operated turnouts. Although some railways use point locks which are actuated by the mechanism separate from that, more commonly the lock is a part of the point-operating mechanism. In the case of the switch machines, the lock is usually contained within the machine. If you look at the picture, you will see that one of the rods coming out of the switch machine is connected to the midpoint of the lock stretcher bar. Inside the switch machine, the rod is connected to the lock mechanism. As the switch machine completes the point movement, it engages the lock mechanism, so preventing the rod, lock stretcher bar, and the switch rail from moving until the switch machine is powered up again to move the points to the other position. In a summary, turnouts consist of three main parts: the switch part, the connecting part, and crossing part. The switch part is the most critical component. It includes a movable switch rails that guides the train from one track to another. The position of this switch rail is controlled to determine the train's path. The connecting part comprises the straight and curved track sections that connect to the switch rails. These sections ensure a smooth transition for trains as they move from one track to another. Proper alignment and maintenance of the connecting part are crucial for safe and efficient train movements. The crossing part is an area that track intersect or cross. These components play a pivotal role in ensuring that the train rails can transition from one track to another smoothly without causing derailments. The design of the crossing part varies based on the angle and the size of the turnout. Understanding the functions and the intersections of these three components is essential for the railway engineers and operators, as it is a key to efficiently routing trains and ensuring safe and reliable rail transportation. Alright, that's all of the lesson today. See you next time.